So here are some thoughts I've had about the more and the less in metaphysics and the more and the less in measurement omission in epistemology. Not my ideas. I wish I've learned these from other people, but this is some of my thinking and grappling for thoughts about those things in the philosophy of mathematics. So one thing we need to do, I think, in my opinion, to get a good philosophy of mathematics, to be able to have an objective, rational philosophy of mathematics, is to see an idea that's been around for a long time, but hasn't been understood in the right way or put into epistemology until more recently. So, people have known for a long time that there are entities and attributes. Attributes can come in a range of measurements, more and less, taller or shorter, stronger or less strong, faster or slower, more intelligent, less intelligent. There's all these things we can look at like that. Some we're able to measure mathematically. People figured out how to do some of that a long time ago, of course, and it took a lot of conceptual thought, problem solving, figuring out how to apply counting entities to counting attributes, and figuring out what's going on. So people have known, there's things like that. And the Pythagoreans were the first ones, so far as I know, that I've read, that looked at reality as being made up of number. Everywhere they looked, they saw number. And they were right in a sense, but they got the wrong thing. They thought number was metaphysical or physical, because philosophy was like all knowledge at the time, all wisdom. And this is, of course, pre-philosophy. Plato systematized philosophy and developed the first whole entire system. But people had wisdom before then, of course, some systematic thought. And so they thought everything was made of number. It was physical, metaphysical. And so it had some kind of power. It had causal power, efficacy, I think, if I understood correctly. So like even, odd. And it wasn't like numbers we know it today. It was, you can't say, oh, they thought even was like this, ha ha ha. No, you don't even understand. It's not two like we think of it today. It's a different conception that they had. You got to look at their context and see what they were talking about. That's good communication. That's good thinking. Not going with words, but meaning. What's someone's cognitive content? Words help with communication, but they are not communication on their own. Communication, I think it means, if I remember right, etymologically means sharing thoughts, sharing, like being of the same mind, kind of like. And having the same word in our head is not the same thing. We'd have to understand what they meant. And they would think that like male was a certain number, female was a certain number, things like that. There was a ratio in the world. And that helped them do some experimentation and figure out that music was based on harmony. Harmony was based on certain ratios, I should say. And they, it was a long time ago, so you can't blame them. It was a mix of some fantasy and mythology and actual reasoning and science. But as some people know, had this program, but then it was shown incomplete or wrong when people discovered that the diagonal of the hypotenuse of a right triangle, isosceles right triangle, the hypotenuse is not commensurate with the sides. It's not in a whole number ratio. It's not like 3 to 4 or 5 to 8. like one can do with maybe some harmonies of music. If a side is 1 and a side is 1, isosceles is a right triangle, hypotenuse is square root of 2. And they could prove, a long time ago, they could prove it was not a rational number. It was irrational. And that threw things into confusion. That caused Greek math to have to adjust and adapt and take a change. It was like the crisis they had at the time. So they thought number was in the world. And for Plato, he had this idea of the greater and the less. Again, you got this range of measurements that he's using philosophically. Like, as I say, you can be taller or shorter, wiser or less wise, more just or less just. Justice, justice and justice. And so there was the great and the less, or the more and the less. Although for Plato, this was still kind of like a metaphysical principle, but it was a principle of imperfection. It was not epistemological. It was not valid. It was something about how imperfect something was from the forms, the true ideas, the truth. Concepts were, for truth, he thought you had to have something universal, timeless, unchanging, some attributes like that. Whereas experience, things we experience, were concrete, temporary, changing, in flux. You had, the problem they were trying to deal with at the time, conceptually. It's people know really well nowadays, but if you go back in time, it's like totally different. Again, you got to understand context, what they understood. They had to figure out how in our thought, in reasoning, is or is not change and permanence consistent. And it was difficult. Some people dismiss permanence, some people dismiss change, things like that. So this is the part of the context that's happening here. And they didn't have science, Newton, Galileo, some things like that. Newton and Galileo couldn't happen without these. Newton and Galileo, of course, knew experience was valid. We can experiment. If experience wasn't valid, we couldn't experiment. So Plato's not right there. But he had this distinction, and so he thought there's this other realm where there are the forms. House, dog, chair, human, justice. We have some kind of awareness of these ideas in this other realm. The ideas, the forms, the perfect thing, the perfect example of that kind of thing. And then things in the world were sloppy, imperfect, couldn't be like that. They'd be like a little less chair, a little more just, a little less just, things like that. So it was a metaphysical principle of like defection. And then for Aristotle, he got that idea also, and he would look at it in biology, in things. It wasn't a principle of defect, it was a principle of existence. I gotta look into it more, dig into more detail, delve into things, dig into the dirt with our fingers about what Plato thought about this, what Aristotle thought about this. This is just a general idea. See what's going on. See our progression. But Aristotle knew in the world that there was the more and the less. He studied biology. He was more into biology and philosophy than into like physics. He loved biology, dug into it. Darwin recognized that too. And you find that a lot of biologists, they recognize how great Aristotle was in biology for his time. They pay tribute to him, the great work he did for what they knew at the time in that context. And you know, and then like for what they thought science was, what they thought reasoning was, everything like that, all these cognitive constraints they had like on their context, what they knew, what they couldn't know. He did a good job. And there'd be like beak sizes, you know, the more and the less, which, you know, Darwin later recognized. And size of feet, size of hands, length, all these biological attributes came in the more and the less. So it was something real, and it is. The thing we need to see is something that happened more recently, but again, this was possible only after some Galileo and Newton seeing what Aristotle did and some other people, and getting his ideas and going beyond them, developing them more than Aristotle could at the time, developing his ideas about induction, abstraction, concept formation. So Newton, Galileo, and people had some ideas, and they came up with some methods and used them, and we call them, you know, Mill's methods now because Mill wrote about them. But one thing they did was see how a variation in one thing causes a variation in another. When there's a change here and related to a change here, and you know in context it's causal, you know. Well, when you see the changes in a certain context, you know there's like A causes B, B causes A, where there's a mutual interaction going on. It's more than numerical, more than statistics. So that was a way you can show causation with these changes. And then, you know, you got, makes sense, like F equals ma. Change in force, change in acceleration. Or with a given force and a given mass, or a given force, let's say, change the mass, the acceleration changes. Things like that. These are cognitive methods used to show relationship and causation. And Galileo did things like that with the like length of a pendulum and the period. You know, he studied pendulums and inclined planes and free fall. You know, figured out, came up with a way to measure the force directed down a ramp for different angles. So when the angle changes, the force down the ramp changes. You got these relationships like that. And they were doing some of this. And so you got this relationship, but it's, you know, limited. Like, what about love and justice and color? They could be purely qualitative. But Newton comes along and some other people, and they see that, oh, light is associated with a wavelength and a frequency. And people figure out that out with sound. You know, we knew about sound and all these different characteristics of it, and then we see, oh, there's just the nature of sound is that it's not like some purely qualitative thing. It's got attributes. We can measure those, and different attributes, characteristics of sound can be associated with different measurements, you know, having to do with wavelength and all that, pitch, volume, and all that. And so we see, oh, some things we thought might have been just qualitative actually correspond to certain measurements. So when we get the concept of red, it's not purely qualitative. It's our, you know, when we learn more about the nervous system and all that, we see that, okay, red is the way we experience this kind of wavelength in this context. Because, you know, our perceptual system is made for moving in a 3D world, not looking at 2D things. That's a mistake some people make. Look at the ecological approach to visual perception. They've got some of this worked out, thought about correctly. You can avoid some errors that some people make in this regard. And like, I don't know who else has a better approach to this than some Platonists or Cartesians or whatever. Cartesian, someone influenced by Descartes. But green, red, yellow, there's certain wavelengths and frequencies we associate with those. It's, again, in a context and so on. And, because it's about how we perceive the world, not just some, measurement as if we're an instrument, like instrument physics. But we see this idea, and then we can, in the objectivist theory, more recently, really developing this to all concepts, we see that everything can be characterized by, other characteristics come in more and a less. Okay? More intelligent, less intelligent. More emotional, less emotional. More calm, less calm. There's all these things. Something's made up of its characteristics and attributes, and those usually have a range of values they can be in. Usually it's a continuum, sometimes maybe it's discrete, but you have to survey the field of every attribute and everything to really check on that. But same idea, you got this range of measurements, and we use those to form concepts. So we look at, let's say, waiter or waitress. We'll go with an easier example, maybe, like I used before, projectile. You can see certain things about a projectile in contrast with other similar things, and it's in a context. We don't, just as we don't form the concept of red in contrast to heavy. Oh, look, here's a red thing, here's a heavy thing. Oh, red, obviously, or red versus wise. That's not how we form it. Red we get by contrasting with other things that are similar. Red versus green or yellow. And then when you get more abstract, you can go this thing versus this thing. Maybe do some contrast, but in terms of forming concepts, you got to have some similarity like that. Or with, let's say, so we got the different colors. You can look at, as I say, projectile. You got things moving in the world. You don't form projectile in contrast to red or out of nowhere. It's in a context of things moving in the world. And you got things dropping. You can push something along the floor. You can throw something. You can see it propelled. You learn how it feels and how they're actually different. You got firsthand experience of the causation. Different causes produce different effects. Firsthand directly from experience. And then we can see that inductively that other things are doing the same. I throw it, someone else throws it. I throw it, it gets shot by a gun. You still got these projectiles. They're in the same causal environment, under the same causal factors, influences. And so there's an initial force, and something goes off in a horizontal direction, and it's pulled down the ground locally. It's not just like something just dropped. It's not like something pushed on the ground, as you say. And it's not like a feather thrown or a feather dropped, because those are affected by air resistance too much. These are things where air resistance is not relevant. We can abstract away from it because it's not relevant to our understanding of what's going on. It's not worth our time thinking about. It's an insignificant factor. And then we see it's pulled down by gravity, whatever that means, a force, a bend of stuff around the earth that makes it move a certain way. I don't think Einstein's right. There's no such thing as time and space as things. There's just stuff. And some people are working on that the stuff around the Earth is what's changed. And that's maybe why there's gravity instead of some kind of like force. But we'll see. People don't know yet. And so notice we have all these things with the projectile, all these measurements. There's all these attributes. They have magnitudes. So you got a rock or a bullet. Those are entities. They are things. They are discrete. We can count them. A rock, a bullet, and they have attributes. And we abstract away from what's not relevant and focus on the things that are relevant, like the shape and the speed and the up and down motion. And then we see with the causation, it's got to be pushed initially. The projectile is a thing that has some initial force on it that doesn't happen after that, just some initial force that makes it go at an angle. And then it goes up a little bit while it's going sideways. So we focus on things like that. We omit these other attributes as not relevant to forming the concept or understanding the situation. We know it has to have some mass, but we abstract away from that. It's got to be within a range of sizes. It can't be bigger than the Earth. If it's bigger than the Earth would go around it. It wouldn't be a projectile. It can't be too small. If it's too small, then it's going to float around in the air, and it's not going to be a projectile. It's got to be a range of sizes and a range of masses. Again, if it's too light, really, really light, it's going to be like knocked around by the air molecules. Again, if it's too heavy, then the Earth would go around it, things like that. Color, abstract away from it. Density, abstract away, things like that. And when Newton was doing some of his experiments, he actually experimented with some things like that. When he was doing some of his pendulum experiments, I think. What would happen if it's different materials, different mass, different density? You got to make sure it's the same effect every time, to make sure you've got same cause, same effect, and there's not some other factors that are going on. But we abstract away from all these things, but you can think about others. And in the situation, like, it doesn't matter the exact humidity level, the exact temperature. There must be a temperature, but it can be a range of things. There must be a humidity level, but it can be a range. And things with the projectile, things with the context. There must be an inertial force, not too much, not too little. There must be some. If it's like too much, it'll like shoot off into space. It won't be a projectile. Too little, won't go anywhere. Not enough to like make it really move. So we abstract away from these. We know there's got to be a range of measurements. Look at the ones that are relevant, then we form the concept of projectile. That's kind of the idea. So now we can apply that to mathematics. So, and some of this is easier because instead of looking at really having to know the nature of things, like what's the essence of a human? What's the essence of justice? What's the essence of government? What's the essence of a force? What's the essence of periodic table, like periods, patterns? Get a certain pattern, what's the essence of it? Things like that. All these things, whatever in economics, finance, a concept, a principle. What's the essence of money? What's the essence of free trade? What's the essence of fitness? What's the essence of country music? What's the essence of heavy metal? They have a nature. But with math, we don't need that. We just got to see that there's a thing, that there's an attribute. We can measure it. And attributes, in ancient Greece, they called those things, ancient times, magnitudes. So we got attributes of things. They are magnitudes. individual things that repeat are multiplicities. 1 human, 2 human, 3 human, 4 human. Although for multiplicity, you might wait until you get to like 2 or 3 or 4. But so here we see the things have a range of how much they are in the world. There's this long, this long, this long, this long, this long. They have some specific length or some specific definite finite intensity. But we omit that measurement and look at the range to form a concept, as we do with red. All these things within this wavelength and range, the border cases don't matter what we do with those, but we know that there's red. And then some border things, there's different options of what we might want to do. Then this stuff over here is green, and this stuff over here is yellow. Transitions in between, I don't care. There is a green, there is a yellow, there is a red. How we deal with the transitions, there's, it depends on our cognitive need and other objective factors about the world and how we think. But we get this range of values, and we get the concept of red. Or there's more stuff going on with maybe projectile. Or with like this, even before we got the concept of 2, if there's person, person, dog, dog, we omit all these measurements of how much they weigh, how tall they are, how intelligent, how fast, how far their step is or whatever. We omit all these measurements and just focus on the fact that there's a one-to-one relationship like that. The multiplicity is the same. And that's how we're forming the concept of math. It's looking at range of measurements and omitting everything except one measurement. Like that there's this many or this many. And similar in like function, the advanced concept of function. We look at the context that comes into play in, and we have a context, make some contrast, get some similarities, and you see some things like these mental relationships are different than some others, like y equals x squared is different than x equals y squared. And with this, one x value gives us one y. With this, one x value goes with two y's. And then we can see how, and it comes into context. I think the concept of function was developed in the 1600s. I got to look into it more, but with people were struggling with, then it developed more. People were struggling with coming up with some important concepts for dealing with mathematical relationships in context of algebra and coordinate systems. And then you can go back and see, stuff people had before, you could put in this context and call a function as well, like a is pi r squared. Area of a circle is pi times radius squared. Or area of a square, a equals s squared. You get a length, and that gives you one area. It's not ambiguous. One length gives you one particular area. One radius gives you one particular area. And that kind of thing would be a function. Or if you do this process, subtract some things, take their ratio, take a limit, does that give you one particular answer or not? We want to be useful for a lot of situations. We want derivatives that are functions. We don't want to have some kind of derivative that says the slope at a certain time is two different things. Here at this time it's going 5 miles an hour and 7 miles an hour and 16 miles an hour, that's like not helpful. That's not what we use. That's not how the world actually works. We need these mathematical things, mathematical relationships that have, say, like, at one time, you got one velocity. And to get the concept of function, we abstract away certain things. We know that. So, see the process is coming into play here. We got the more and the less still from a long time ago, but now we see how it's something in the world that we're processing in a certain way with our minds to form certain concepts. So we get like entities and attributes. We can form concepts of those. And then we can go back and see the math that was implicit there. That, you don't got to know about wavelength or be able to measure it to get the concept of red. Most everybody can do it. But to go back and see what measurements are there, that took a lot of complex, abstract, scientific discovery. Or even an easier one like weight. Some people are heavier than others. We get that idea. We know people have like weight, but then to measure it is different. We get the concept of person, get the concept of weight as an attribute of people or other things, and then we got the idea of weight. You don't have to know anything about doing math to it, but then we can bring that back into play and see that, we know there's a more and the less. It's given in perception. Now, when we get this thing that we call 1 pound, we compare it to this person. This person is like 120 of these or whatever. So it's, with the objectivist theory, it's the math is bringing back and unraveling things that were there in the first place that you kind of omitted to form the concept of weight as an attribute, like of a person or something else, just weight in general. Things have weight. That's some of the idea coming in where we have, as I say, attributes like weight. We got these in their weight is along a continuum. You got this magnitude, and then we conform the concept of weight by saying there's got to be a range of values, and then bring back the exact measurement later by getting this standard, this thing that's also a weight. We compare a weight to a weight, something with weight to something else with weight. But this is called our one, and then we compare it to the person. So we're having this idea of the more and the less. We see how it comes into play in forming all these concepts in math as well. Clearly it's like with height, but then we see it's with red or some attributes that sound like pitch. Then we can see it's with all concepts. Then we can see, math, the concept of math are not like something special. They're not fictions, as some people say, because they didn't have a good epistemology or metaphysics. I didn't. I learned this from other people. I wish I thought of it on my own. But it's difficult, so I understand. People say math is a fiction, although it's wrong. Social game, they say it's just a formalism, like David Hilbert, because he didn't have a good metaphysics or epistemology. Or they're Platonists, or they come up with set theory because it's supposedly just in the mind. It's like, I don't know how it comes from reality. I don't understand epistemology, so let's just be like Copernicus and make up some little computational method, and that's our set theory. It's wrong. It's cool. It took genius, but it's not right. That's not how we form the concepts. That's not the standard. The standard should be how we really form concepts and where they come from in reality. We should look at metaphysics. What is the world like? Epistemology. How do we process that? Then we can be objective. Then we see an objective theory of math. We see how the more and the less comes into play in forming concepts. It's in the world. a range for red, a range for height, different things for function. Like with a function, it could be like how many things or how big a range of values here is related to how big a range of values here, like radius, area, or some like times some lengths and the time it takes to run that length for a certain person or whatever. There's different lengths the person can run. There'll be different times. There's just different ranges of values, or how far has the Earth gone, and how long has that taken. The range will be a lot more than it would be for a person running. Things like that. So we look at the size of the range doesn't matter. There must be they get bigger and bigger, and then we can abstract away and say it's in the real world it's finite. The only thing that exists is stuff that exists. They're finite. They have an identity. We can abstract away. Infinite is not a thing. Infinite means there's not a given finite, definite bound on our numbers. We could make the ranges a little bigger. Then we can abstract away, a little big, a little bigger, a little bigger. You abstract away and see, oh, there is no going forever, but there is, we could get more. We could add to the magnitude. A little more, a little more, a little more, a little more length, a little more and all that. That's the idea. And so we get these, like the ranges could differ, or we could abstract the idea to be like concrete things. These people related with some function, like how a spring works or whatever, to their weights. We could have these things to these things, and that could be like a function. But there's the number of things is abstracted away from. There are measurements there. We abstract away from the range. And then we get the idea of domain and range. And the complexity of the relationship can vary. There's different ways we can relate this quantity to this quantity, this count or magnitude to this count or magnitude. We abstract away from those. Like all these different mathematical attributes. Then we see the essence of it as, the domain, the range, and a rule that relates them. So measurement omission is coming into play there. There are things in the world that we're referring to, and then there's the way we're processing it. Again, the metaphysics, the epistemology. And it's like the more and the less coming into play in different ways. The more and the less is in the world, and we abstract away from some of that, just as we do with red, range of values, abstract away red, and get the idea of function. Then we can apply that, of course, to some other things, ratio, proportion, all these other concepts in math, integral, derivative. We see that there's, the basic idea of there's the more and the less, as it's been throughout history, there's this thing that's metaphysical, magnitude, multiplicity. We got these ranges of values. Then we got the way we process that. By measurement omission, we get certain concepts, just like we do of red, green, weight, or projectile, things like that. Get that idea, understand them in something concrete, and then apply it to stuff in math. So that's, I think, a nice development. It's an interesting development through history and philosophy of the idea. So notice that we got to go with Aristotle, and see that the more and the less is a real thing that we can know. We see how we know it nowadays because of what some scientists have learned about what's going on with red and green and sound. Then we can apply that to other things like anger and wisdom and intelligence, and apply it to math as well. We see that we get some measurements, like I say, with the function, the more and the less, abstract away. There's got to be some things here and some things here. There's all these different ways we can relate them. There's got to be some relationship where we get definite information. We don't have one person doing a race and claiming that the person did it in 3 different times. What's my grade on this test? Oh, it's a 60 and an 80 and 100. In the same way, in the same respect, in the same time. It can't be, you know? That's not a function. We see those things, we abstract away, we see as a function. That's, I think, the program, again, we need to develop. We need to see how the more and the less comes up metaphysically, how it's used epistemologically to form concepts, abstractions, and principles. Then we're going to be able to really dig into mathematical concepts and delve into them and understand them for the first time in history. But again, I didn't think of this. I wish. This is some concepts and principles I learned from other people, like Pat Corvini and Aristotle and the objectivist epistemology and metaphysics. And so, you know, the more and the less, that kind of thing is not a defect. It's what gives things existence. To exist, the law of identity, you got to be something finite. You got to have certain characteristics in a finite way. Not finite means not definite, not existing, not having identity. So it's not a defect. It's something that makes knowledge possible. It's not something that keeps us from knowing. It's something that makes knowledge possible. And then it's how we deal with these, with cognitive processing, that gives us our abstractions. This process of measurement and omission, like some but any. It's got to be some range of values, but it could be any. And math is not like the Pythagoreans thought in the world. It's not like Plato thought something out there. Math is a tool we have to cognitively process things. So the magnitude, again, and multiplicity is out there in the world. The more and the less. But mathematics is a science we have for dealing with those things. So there's not a thing that we're identifying or knowing when we get the concept of two or function or derivative or whatever. So for Plato, you know, you'd have some awareness of a thing separate from reality. You ignore the measurements, they're like error to be dismissed. They're wrong. They're not telling you what the essence of something is. For two or triangle or hexagon or function or derivative, you know, the particular concrete things, examples, experiential stuff is defective. And for Aristotle, you know, still there was some essence in things. Essence was metaphysical. There was still like manness in all men. This like Platonic remnant of his thinking, as some people have called it. Like maybe two-ness in some things, or chairness or justice. But here we see with the more and the less and measurement and omission how they play out in metaphysics and epistemology, that the essence of things is epistemological, not metaphysical. And it comes from looking at the most important characteristics of something and from omitting measurements. So if, like, providing a seat is the essence of a chair, still there's a range of measurements for that we abstract away from to kind of get that idea. Or because he can do it like more or less well, kind of. And it's not, you know, that the thing that Plato would call a defect is not a defect, but is an essential, important part of metaphysics and reality and individual things that from which we get the abstractions. So we see this development of thought that we've come to now. That the more and the less is out there, as Aristotle saw, as Darwin saw, as Galileo and Newton saw, as we learned even more since then. You got these magnitudes and this more and the less out there. It's in our consciousness, and the way our consciousness functions, forming abstractions, is a process of measurement omission, as you see, of doing something with the more and the less. Knowing that, like with red, there's shades of red, but we see this stuff is red. We abstract away from the darker or lighter shades, even if we don't know wavelength or frequency or something like that. We abstract away from darker or lighter shades of green. We still get the concept of green. We got this range of measurements, and we get the range, and that's how we form our abstraction. That's how our mind is working. So that's, in short, like the development of those ideas. We need to develop those to really understand mathematics. Again, this is some of my thinking, or that was some of my thinking and some discussion and some grappling for thoughts about the more and the less and measurement omission in philosophy. The more and the less, magnitude, attribute, entity in metaphysics, existent, and then entity, unit, measurement omission, the more and the less in epistemology. Some thoughts and grappling for thoughts about those things in the philosophy of mathematics.